Hello everybody, welcome to my channel. Today we are going to discuss about differential equation. Differential equation is a very important topic in 12th examination and it is widely used in different type of competitive exams also. Beside this, it is mainly used in to calculate or to derive different type of equations such as heat equation. So it is so important to learn about the definition and the main concept of differential equation. In this video, we are going to learn about definition of differential equation, order of differential equation, degree of differential equation, along with some questions. So let's get started. What is the definition of differential equation? Any equation that involves differential coefficients or derivatives, for example, dy upon dx is equal to 2x plus 2. Any equation. What is equation? Do you have some knowledge about what is equation and what is polynomial? What is the difference between a polynomial and an equation? Polynomial, for example, 2x plus 3y. This is called a polynomial. What is equation? 2x plus 3y is equal to 5. When there is left hand side and right hand side, that is called an equation. So any equation that involves differential coefficients means derivatives, that is called a differential equation. So here dy upon dx is equal to 2x plus 2. This equation involves derivative. 1 derivative, 2 derivative, 3 derivative, it doesn't matter. Any equation that involve derivative, that is called differential equation. It doesn't matter that it involves any constant or any variable. It is just important that that equation will involve one derivative. So this equation dy upon dx, when we take right hand side to left hand side, minus 2x minus 2 equal to 0. This is called a differential equation. Any polynomial with left and right hand side is called equation when we take right hand side to left hand side, it will equal to 0. This is definitely an equation and it involves derivatives, so it is a differential equation. Now second example, d square y upon dx square. D square y upon dx square, that is second derivative, first derivative plus any constant. Dy is equal to cos x dx. This is also a equation when we take dx to the left hand side. Dy upon dx is equal to cos x. Dy upon dx minus cos x equal to 0. So it is also a differential equation. Here d square y upon dx square plus 3 dy upon dx plus 2 equals 0. It is also a differential equation. It doesn't matter that if there is second derivative, third derivative, fourth derivative. Derivative should be involved in the equation. What is dy upon dx? Students who have already solved derivatives chapter, they know about this. Dy upon dx is basically a derivative. What is the meaning of dy upon dx? Y here is a dependent variable and x here is an independent variable. Basically a derivative means if one thing change, then what is the impression or what is the change in the second thing. For example, if we cover distance in a short time, then speed will be more. So what is the dependent variable and what is independent variable? If we increase speed, then distance will be less. So what is dependent variable? That is on the numerator part, and what is independent variable? That is on the denominator part. So basically a derivative shows rate of change of y with respect to x. Rate of change of one thing with respect to x. How much change occur when we change independent variable along with dependent variable. So this is the meaning of derivative here. So what is a differential equation? An equation that involves differential coefficients or derivatives. They are the same thing. For example, dy upon dx is equal to 2x plus 2. This equation can be solved equal to 0. So this is the equation. This is also a differential equation. This is also a differential equation. Now we will learn about order of differential equation. What is the order of differential equation? It is the order of highest differential coefficient occurring in it. What is the order of differential equation? Highest differential coefficient order. What is the highest differential coefficient? Highest differential coefficient means highest derivative. Highest derivative. Now, order d square y upon dx square. What is the order of this differential equation? D square y upon dx square minus 2 equal to 0. What is the order of this differential equation? 2. Highest order derivative is second derivative that is occurring here. So order of this differential equation is 2. In this example, dy upon dx whole square plus 7x plus 5 equal to 0. Here derivative, highest derivative, that is dy upon dx. That is dy upon dx. Only first order derivative is occurring here, so the order is 1. You should not confuse about the power. Power is basically a degree that we will discuss later. Order of differential equation is highest derivative that is occurring in the equation. Now d square y upon dx square plus x dy upon dx plus 2 equal to 0. What is the order of this differential equation? Order of this differential equation, highest order. This is the first order differential equation. This is the first order differential. And this is the second order differential. So order is 2 here. What is the degree of differential equation? Degree of differential equation is a little bit difficult concept. It is the highest power of the highest order derivative after it has been expressed as a polynomial of derivative. To find degree of differential equation, first it should expressed as a polynomial of derivative. Then we can find degree. And what is degree? Degree is highest power of highest order derivative. For example, d square y upon dx square plus dy upon dx plus x equal to 2. If its power is 2, what is the highest derivative is occurring here? This is the first order derivative, this is the second order derivative. Second order derivative is highest order, and what is the power of that? That is 2. So power of differential equation is 2 here, and that is degree. Highest order differential coefficient power, that is called a degree. What are the conditions to find degree of differential equation? Sometimes differential equation is not represented as it is in the simple form like this. If that is not represented as it is, then we have to first represent that differential equation in a polynomial of derivatives. Then we will solve the degree. Condition 1, equation should be polynomial of derivatives. No negative and fractional powers are allowed. If derivative power is 1 by 2, that is not called degree or negative. Powers of derivatives should be natural number 1, 2, 3 to n. For example, d square y upon dx square cube minus dy upon dx plus 5 equal to 0. Here degree is 3 and order is 2. Highest order derivative, that is second derivative, so order is 2 and the degree is 3. And it is already expressed as a polynomial of derivatives. No negative fraction powers. This is a natural power, natural number. So all the conditions are satisfied here. If we are not able to write it in a polynomial of derivatives, the degree is not defined. if we can't write the given equation in polynomial of derivatives, then degree is not defined. We will discuss it in questions. First question is find order and degree of the following: d square y upon dx square plus 3 dy upon dx square x square. So first we will solve this equation as a polynomial of derivative. We take LCM of these two terms. These two terms we take LCM and then we cross multiply them. Then we again cross multiply. After that we get d square y upon dx square and first derivative power 2 plus 3. And then after that on the right hand side we get x square dy upon dx whole square. So what is in this equation, what is the degree? Highest order derivative. This is a first order derivative. This is also first order derivative. What is the highest order derivative? That is this. Second derivative is occurring in this whole equation. And what is the power here? Nothing. That is 1. So the degree is 1. Highest derivative power, degree is 1. So first you have to show this in polynomial of derivatives by solving the equation. Then you have to find degree and order. What is the order here? Order is second. Order is 2 because highest order derivative is 2. Next question is sin dy upon dx plus xy equal to 7. Order of the differential equation. What is the highest occurring derivative here? That is first order derivative, and so order is 1. Degree is not defined here. Why degree is not defined here? Because it can't be expressed as a polynomial of derivative. There is no expression of polynomial of derivative. We can't write it as a polynomial of derivative. If it is like dy upon dx plus sin x plus xy equal to 7, then we can write it as a polynomial of derivative. But dy upon dx is not separate here. It is in the sine function. So degree is not defined. Order can be defined, but degree is not defined here. Next is question sin d square y upon dx square is equal to y. In this, we can write d square y upon dx square. Sine, we take sine to right hand side. It will become inverse. Now we can write it as a polynomial of derivative. Highest order derivative, that is 2. So order is 2. And the power of highest derivative is 1. So degree is 1. In this equation we can't do that because sin dy upon dx is equal to, if we take other side, minus xy equal to 7. We can't write it as dy upon dx sin inverse minus xy. This is not defined. We can take inverse with y only or x only. So degree is 1 and order is 2 here. Fourth question is sin d square y upon dx square. We take sine to the right hand side. Highest order derivative is 2, so order is 2. And what is the power of highest order derivative? That is 1. So degree is 1 here. Fifth question, d square y upon dx square whole cube minus 7 dy upon dx plus 5 equal to 0. This is expressed as a polynomial. Yes. What is the order? Highest order derivative occurring here, 2. And what is the degree of highest order derivative? That is 3. So with this, we already know the definition of differential equation, concept of order of differential equation, and degree of differential equation along with some questions. I hope you understand this topic. Thank you.